Hello everybody, my name is Kai Werner and I work as Technology Evangelist for TIBCO. Today I want to present you a case study and lessons learned about how we move with our customers from a monolith to cloud, containers and microservices. This is the most recent session from February 2017 which I presented in Mumbai at a TIBCO meetup. So the main goal of microservices and all these cloud native things is to adapt the evolving demands from the business. And the key here is really on the left, the agility and speed, that you can do changes more quickly and have reduced cycle times. Web scale and low cost are also important, but the key really is to fail fast and do changes of business logic quickly and be innovative. This is the key motivation why we see this journey from our customers moving towards microservices and cloud-native architectures. For that, let's take a look at the agenda, and here I really will tell the story of how some of our customers already did this move, at least in some parts. Nobody does a complete migration of their projects, of course, but for new services or new parts of a project, it makes sense to think about this. And we will see how a legacy monolith application can be moved towards microservices and a cloud-native platform to build cloud-native microservices. The session concludes with a demo where we leverage our TIBCO middleware together with modern cloud-native technologies like Docker, Kubernetes, Cloud Foundry, Console, and Spring Cloud Config. Let's begin with the situation which many customers and enterprises have these days, a legacy monolith application. And this graphic here, you will see it through the whole recording, and here we will see how this evolution continues. Here in the middle we see the monolith. In this case it's a big SOA application. In this example from the case study, it's middleware and Java, so TIBCO BusinessWorks for integration middleware and some Java web services. This monolith is one big application with several services and runs on virtual machines like VMware. It's cloud ready, that means you can already run it on Amazon or so, but you will not leverage all the features. So in the end, you have different VMs and there you deploy different application monoliths. These integrate to many different external systems like legacy, mainframe, CRM or some cloud services. And of course we have not just one monolith but many of them. The key lesson learned here before we move towards microservices: on-premise will not die and also the monolith will not die. Not everything will or should go to the cloud or to microservices. Often it's the better case to keep it as monolith. However, then you will not have all the agility and flexibility of microservices. In this monolith, various technologies are glued together. In our case, it's especially middleware from TIBCO and Java E services, together with some Python code for scripting and some JavaScript for some web application and UIs, and VMware for running the instances and applications. So a lot of different technologies already. About development environment, well, TIBCO does especially visual coding, which has a lot of advantages, but also you write some source code, either if you need or if the developers like it more. And in most projects, you see anything in between, just zero coding or code everything. And that's absolutely fine, and I think that's absolutely what we will see in the future too, to leverage visual coding sometimes, but also be able to write custom source code and combine that in the same IDE, including debugging and all these features together. Therefore, lesson learned number 2, which I especially have to talk about when I go to coding conferences where people do not use products or tools. So visual coding in the meantime works. Forget the old source scenarios 10-15 years ago where the old ESBs did not work and the tooling was horrible. Today it works very well, and also for very complex scenarios. So for complex mappings and transformations, for examples, you can do that without any line of code. However, in the meantime, it also can be better combined with coding. In the past, the tools were very proprietary and you could not simply add Java code or debug it together. That's the history. Today this is possible. But now let's go to a more agile architecture and move towards microservices. I will use just one slide to talk about microservices, as everybody heard it already probably. And here is a good example of how we have one big application and we want to split it up in different domains of business logic. Here you see an example where red is one domain for booking flights, and here we have the green services about customers and inventory. And we have another domain which is also related to ticketing, customers, and so on. These are simply divided and split up into different microservices. So each tile in the end is a microservice, and it does not matter how small or big it is. So this term is a little bit confusing. The key, however, is that all these microservices are independent of each other for development, testing, operation, deployment, and also then versioning and updating. And that's the key benefit of microservices, to get shorter time to results and increased flexibility and scalability. You can easily replace small parts of an application instead of changing the whole application. And that's true for the whole lifecycle, not just development, but also testing, deployment, versioning, and so on. This is really the key advantage. And this is not dependent on any technology change or something like this. And this is often the first step from a monolith to microservices. Let's take a look back at our architecture and case study. Here now we see no longer one monolith, but we have split it up into different services. For example, one business service in Java, one business service or script in Python, and one integration service with our TIBCO middleware. So here they still run on virtual machines and nothing else changed. No new technology, no containers, no cloud platforms, and also no new technology for writing the middleware. You can still use the 10-year-old middleware version which you used before. You just split it up, and for that you already get some more agility and flexibility. Huge advantage already without many changes of the code or technology. There are various forms of microservices. Here we see the SOA with different services. This is SOAP or REST or messaging services. Then we build integration services which orchestrate different SOA services. But we also have monolith applications which cannot be split up, like legacy mainframes, for example, or any proprietary solution which you simply cannot change anymore. And there you still can expose individual services out of that. For example, IBM mainframes already support exposing parts of the logic via REST or SOAP services. And then again, you need integration services to orchestrate and integrate all of that with other microservices. So you here see also it's a SOA service, a web service, a microservice, just a service. The term doesn't matter in the end. And also we have SaaS services, software as a service. This is things like Salesforce or Marketo, where you have no control about that. You have no control about the features, no control about the versioning when they update and migrate to new releases, when the old service is no longer supported. And all of these have to be integrated together. So integration is key for success in a microservices world. And also true for BPM, where you have some human interactions. With all these microservices, let's take a look at this distributed microservice architecture. So here in the middle, you see the microservices itself. They are here very small, A, B, C, D. That's a pretty nice example. Here you have the business logic and it's flexible and independent. However, it's just the inner architecture. With microservices, you have many new challenges instead of using a monolith, like load balancing, service discovery, failover, client-side load balancing, caching, and all this distribution and those things. And configuration is distributed, how to analyze the logs. So the complexity really has moved and increased to the outer architecture. And that's a completely game changer. So you do not just develop a monolith anymore, but many microservices plus all the logic around this. Some new design patterns emerge with this. For example, the circuit breaker for resiliency to prevent cascading failures. I do not want to go into detail into this pattern here because we see it in the live demo later, where we leverage BusinessWorks Container Edition together with its native integration to the Hystrix implementation of the circuit breaker, an open source framework of Netflix. But you have to understand that Cloud-Native Microservices bring in a lot of new patterns which you need to implement. So we already know the enterprise integration patterns for filter, transform, content-based routing, and so on. And with microservices, we get new patterns which we have to think about to solve our problems. Therefore, lesson learned number 3, microservices are not free lunch. They do not fit into every scenario. That's very important to understand. In addition, when you design microservices, you have to think much more about open APIs and API management, because in contrary to the past, you do not have the monolith or the proprietary solutions, you have individual independent microservices which have to interact with each other, with not just your internal services, but also with partners or with the public cloud. And also, of course, you want to leverage other cloud services which you do not control by yourself. And you need to expose your microservices to others so that they can use them easily. So from the beginning, design microservices in a way that you can expose them to others so that they can use them by themselves in an easy way. That's a very important point to be successful with microservices. Again, new design patterns emerge, for example, the backends for front-ends pattern, where you have to think about all these microservices and the bottom right, and then you have all these different interfaces where you want to connect to, like mobile devices, Android, iPhone, but also a web browser and other applications like Xbox or PlayStation, for example. And in every case, you want to just offer some different parts of the microservice business logic to these different devices. The same is not just true for these mobile devices, like an example is Netflix, but also for other scenarios like banking customers, where they want to expose some functionality just to some specific partners and some others to some public, depending on the device. So again, a lot of new things to learn, and that is completely different from the monoliths which we implemented before. Therefore, the next step in our evolution now is to add API management. Design your microservices with Open API in mind, and then add API management to expose these services to the public and leverage API features like caching or throttling, depending on the service consumer, which again can be internal, a partner, or external. Now, this is already a pretty good evolution, and we are getting much more flexible and can innovate much easier. Lesson learned number 4, design microservices with open APIs in mind. That's what Amazon is doing since the beginning, and they are very successful with it. And others do the same thing, like PayPal and all the new economy, and we should do that in our enterprise projects too. Now we have already microservices. No new technology yet, but still we are already flexible, and now let's move to the next part to be even better and to be able to scale out and leverage all these cloud-native features. But what does that mean? First, what does it not mean? You should not use cloud washing. That means to rebrand an old product or service and just deploy to the cloud in Amazon, Microsoft, or Google Cloud Platform, and then say, yeah, you have a cloud-native service which you can now use. This will not work because you cannot leverage all the features, you will not be flexible or innovative because you have just legacy deployed to the cloud, and then you will even have more problems with that. However, what should you do? You should, for example, leverage the 12-factor apps. These came out by Heroku, a platform as a service now owned by Salesforce. And in the meantime, it's not just 12 factors or best practices, but even more, maybe 13, 14, 15, whatever. Here are just these examples which you should definitely use for microservices to be cloud ready. For example, you should have a tracked code base, you should manage your dependencies and a central configuration. You should have baking services, so all your microservices still need things like a relational database, for example. And this can be included as a baking service which can be accessed from the different microservices. Automation, centralized logging, concurrency management, port binding, a lot of other examples, what you should think about in the beginning when designing microservices. Again, it's not just for free lunch if you want to use microservices. And to get all these benefits on focus on business problems, to be more innovative and agile, this is exactly the point to leverage these 12-factor apps, and then you can also leverage things like service discovery and realize load balancing and failover. The key points really to being cloud native are that you have self-service services and multi-tenancy, so that you can deploy and scale services easily also for different service consumers. A service consumer could be another department, a partner, or an external user. And you should be vendor agnostic to deploy your services wherever needed. Lesson learned number 5, cloud native means much more than a cloud washed application deployed to a cloud provider. You need to leverage these new concepts and to deploy your microservices successfully. No matter if it's in the cloud or maybe on premise, that's also possible, and also hybrid architectures are getting more and more important. So how do we realize cloud native microservices? Yes, there is a momentum of containers, and they are getting very, very important because they have so much flexibility and advantages. Docker has highest momentum right now, but we also see other technologies like CoreOS Rocket, or Cloud Foundry uses its own technology garden. And that doesn't matter so much from the business perspective of what kind of integration or business service you want to implement. But this is really the beginning. And why do you need these containers or use them? See on the left, you have a much smaller size than in virtual machines. The startup time is much faster, and you can integrate it much easier in your environment. Think about continuous integration, continuous delivery, DevOps. You can integrate a container much better here than a virtual machine. And therefore you get much more lightweight, get better resource utilization, and get platform agnostic because you can run your containers everywhere. And then finally with that you can innovate and fail fast if needed. Our evolution continues. Now we do not deploy everything on virtual machines. Now we deploy every business service in a container. This still can run on virtual machines or on a cloud platform under the hood, of course. But now it's very flexible, and you can start and stop and version and so on every service by itself. That's a huge step in the evolution. Lesson learned number 6. Microservices and containers are often used together. That absolutely makes sense and is a huge benefit, but they also work very well without each other. That's a thing which some people are not aware of. As I said in the beginning, you can create microservices by just splitting up your existing monolith without any new technology, any new container stuff, and so on. Just split up your old services to be more flexible and control, deploy, test, debug, version every service by itself. And also we can use containers by themselves. For example, in our engineering, we use containers for a long time already to share a specific version of a product, to share it with colleagues for testing, in our infrastructure for testing, and so on. And that's also another huge advantage where you can use just containers, and you can use that for monoliths also, not just for microservices. So how to get to a cloud-native architecture? Containers are an important part, a piece of the puzzle, but only the foundation. Here you see the cloud-native landscape created by the CNCF. So you see here is a lot of different toolings. Depending on what exactly you want to do, you have a lot of different options, both open source and commercial proprietary solutions, cloud services, and so on. Let's think about this from a more general perspective. A cloud-native platform needs an infrastructure as a service. This can be things like AWS or Azure or Google Cloud Platform, or something like OpenStack if you want to do it on-premise. And this manages the network, storage, and servers so that you can create your private or hybrid cloud and that you can self-host and control your environment. However, to really be cloud native and leverage features like service discovery and like load balancing, have resilience microservices, and to be agile with that, elastic and scalable, you need a platform as a service on top of that. This includes the container management, the routing, the monitoring, and all these things. These together are the very important part to build a cloud-native platform where you can deploy your microservice on. On the market, we see two more or less de facto standards. One is Kubernetes, which is based on Docker, but in the meantime, it also supports other containers like Rocket already. And it was open sourced by Google, has a lot of traction in the open source and field and community. OpenShift is another interesting framework built by Red Hat, which is built on top of Kubernetes. And also we see a lot of other platforms for that. Cloud Foundry is the other one. It's all open sourced and published by Pivotal, but also in the meantime other big vendors like IBM with Bluemix and SAP with their cloud platform leverage it under the hood. And you also can use only the open source version without a vendor, of course. And as you see here, and the same is true for Kubernetes and also some other cloud-native platforms, they manage how you control the microservices. They have health managers to find out if a microservice has stopped or any performance issues, if you have to restart it or scale it out to other instances. You have service discovery to find which IP address the service have. You have the load balancing, the failover, the logging. All of that is managed by the cloud platforms. That's the huge benefit. You get all of that out of the box by these platforms. Of course, you have to learn also the new concepts and how to deploy and operate that. So it's not for free lunch again. There's even more new stuff like Apache Mesos, a cloud operating system, which is very powerful and can be run across different infrastructures like AWS, Google, Azure, on-premise. And on top of that, you can run different cloud platforms like Kubernetes or also big data clusters like Hadoop, Storm, Spark. All of that can be run on the same Mesos cluster to scale it out and manage these different things on one big Mesos cluster. We see containers as a service where you run your microservices directly on a public cloud like EC2 container service, Google's container engine, or on Azure container service. And we also move towards serverless computing where you have the function as a service with 100% utilization. You really only pay for exactly what memory and disk and computation you use. And with that, with some frameworks, you already can deploy microservices either just as code with Java or Python, or even in containers, like on the open source OpenWhisk platform by IBM or Red Hat's Function. There you can deploy containers, which can include a middleware service or a business logic directly as serverless service. So a lot is going on, and therefore a key message is to be cloud platform agnostic. The container world changes fast, and so you should be ready to develop your microservice once and then be able to deploy it everywhere. Just on a container like Docker, in a cloud platform like Kubernetes or Cloud Foundry, or maybe serverless or in a cloud container service or on Mesos or whatever we will see in the next years. So now let's build cloud native platforms with all we have. We have now containers, we have cloud platforms, we have split our monolith up. And therefore, this is now where we want to go in our final evolution. Here now we have one cloud platform, and here we run our containers, which include our microservices, and we expose them via API management to others. And here we do all this integration in the microservices. This now is the first step where we are really cloud native and not just cloud ready, with all this management under the hood of load balancing, service discovery, failover, restarting of containers, versioning, rolling upgrades, and all of these things can now be done easily so that we can focus on our innovation and our integration in middleware services. Containers are lower level technology. That's lesson learned number 8. Only the infrastructure provider should care, but not the application developer. When you use your IDE to write Java code or develop middleware services, you should only focus on the integration logic or business logic, and then export it and run it everywhere without recompiling, retesting. That should be available and is very important so that you can easily make changes and be innovative. Another key component of DevOps, of microservices, is DevOps. Continuous integration, continuous delivery, to do automation. Without automation, all these distributed microservice concepts will not work because you have too much struggling with all these things like management of different microservices, doing upgrades, solving problems, and all these things. For that, yes, you need technologies like Maven, Chef, Puppet, Ansible, Jenkins. But even more important is the organizational changes. Changing culture, developer and operators have to work together. You have to get typically C-level support for this because it's a huge change, especially in more complex organizations like the big banks, telcos, retailers, manufacturers. Therefore, only a DevOps culture and technology and support for the tools to develop this will be successful in a microservices era, to be cloud native and build microservices. Lesson learned number 9, automation with CI, CD, DevOps, and the related cultural change are key for success, especially for cloud-native microservices. Okay, so now we have seen a lot of terms, microservices, cloud container, cloud-native, and so on. Let's take a look at a few examples. If you want to do just coding, then you can use, for example, JBoss middleware services. They run natively on OpenShift and leverage a lot of cloud-native features. Here you use, for example, Apache Camel for coding. WSO2 is another open source example where you can do a lot of microservice building, especially with coding and a little bit of configuration. Here you can also run it on Kubernetes, OpenShift, Mesos, and so on. So these two are really very coding based. So if that's exactly what you want to do, then these might be the right ones. With TIBCO, which you will see in the live demo, we have a lot of visual coding and native support for these cloud native features. So in our IDE, I will not so much focus on the visual coding, but you can also have all that cloud native integration. For example, to these Netflix cloud native patterns, like Hystrix for the circuit breaker, or Eureka for service discovery. And we also support other frameworks like Spring Cloud Config or Console for central configuration management and service discovery. And many more will be supported in the future. And this is really natively. So you can, in the IDE, click and configure what you want to do for these frameworks. And that's a huge advantage. And also you can run all these services on-premise and containers in the public cloud and migrate between these automatically. There is no new coding required. You can run them everywhere. So lesson learned number 10, a cloud-native architecture leverages various programming languages, open source frameworks, and middleware. And a key for success in projects is to combine that to be successful. You can, for example, combine programming languages like Java with middleware like TIBCO and work with that together in the same IDE. Leverage cloud-native frameworks like Console, like Spring Cloud Config and others, and Docker and platforms like Kubernetes or Cloud Foundry. You build your microservice once, deploy it here, and automate all of that. Then you will be successful. Therefore, let's now focus on the live demo with all the combination of this. Here you see the demo setup. On the left side, we see Java code, we see a TIBCO as middleware for building services, and then you develop that and deploy that via automation, CI/CD, DevOps with Jenkins and Maven in this example. You leverage open source frameworks like, for example, Console, Spring Cloud Config, or Hystrix for getting cloud native. And you deploy that either just to Docker or to a real cloud platform like Kubernetes or Cloud Foundry. And you expose your services, which can be anywhere, on-premise, which can be in Docker or on a cloud platform, and expose them via API management, in this case with TIBCO Measury. That's the demo setup. And if you want to see that live, I have recorded 2 YouTube videos where we do that with TIBCO BusinessWorks Container Edition and all these technologies and frameworks I just mentioned. And also another video for focusing on new design patterns with the circuit breaker implementation and its native support within BusinessWorks Container Edition. Therefore, I do not want to go into more detail here. Please watch these other videos if you want to see the live coding for that. However, be assured it's really natively integrated all with each other, and that's very easy to implement all of that with these tools. And key is to combine open source with the middleware to do that. Let's sum this up with the key takeaways. A cloud-native architecture enables flexible and agile development. This way you can become innovative and do business changes fast. Only vendor and platform agnostic architectures are future safe. You need to be able to develop your microservices once with Java or with a product like TIBCO, and then without recompiling or retesting be able to deploy it everywhere, in a container, in a cloud platform, or on-premise or in hybrid architectures. You need various languages for scripting or coding. You need open source frameworks, for example, for the cloud native features. And you need middleware to integrate everything. A key point in microservices with all these distributed architectures, all of that needs to be integrated and orchestrated. Not just the microservices itself, but also with other cloud services and also with legacy systems like ERP or mainframe. That's it. If you have any questions, please write a comment or give me feedback via Twitter, email, or LinkedIn. I'm happy to hear from you what you think about this and discuss it with you in your projects. Thanks for watching.